Okay, can everyone hear me? Yes. All right, let's get started. Thank you all for being here. Really excited to be here with you all for the Dapr maintainer track. This is a special occasion for us. We'll get to that at the end. My name is Yaron Schneider. I'm a Dapr core maintainer, steering committee member, one of the original creators of the project. Came up with it when I worked at Microsoft together with my co-founder for Diagrid, Mark Fussell. Donated that to CNCF. Did that about a year after I donated Kada to CNCF with Red Hat. And yeah, I've been helping organizations adopt Dapr until today. So thank you all for being here and taking an interest in Dapr. So here's some stats about the growth of the project. In 24, we've done an amazing growth. We track the SDK growth. These are all public stats you can get off of pip, NuGet, JavaScript Maven. Python, for example, made almost a 200% year-over-year growth. JavaScript has done 109%, I think. .NET's really going crazy with almost 1.5 million downloads per major version. And these are just the SDKs that we can track through public stats by package manager sites. We're not even tracking the people using Dapr just with HTTP or gRPC. So the project is seeing massive adoption. And of course, as project maintainers, this is what matters most to us. The GitHub contributors. The contributors are the lifeblood of the project. These are the people that go and day in, day out, create issues, create docs, PRs, contribute to the code. Contributions do not need to be code-based. By the way, just engaging in a GitHub comment is also a contribution, which is awesome. And we're seeing the community growing more and more. We've released during this year several cool case studies on the CNCF website. You can check them out. Grafana Labs has an incredibly interesting scenario where they use Dapr to power up a software supply chain that they have going internally. HDFC Bank uses Dapr to process 750 million transactions a month. Vonage also has crazy scale running Dapr across, I think, 100 Kubernetes clusters, if I'm not mistaken, across 3 different clouds, plus an on-premises environment. And Watswater uses Dapr workflows and actors to a very large scale. These are just some of the thousands of Dapr adopters that are out there today. And we're really seeing Dapr being picked up more and more by large platform teams, which is kind of a flip for from the initial adoption pattern that we've seen where developers would bring Dapr into their individual team. They would adopt it there. Dapr would basically expand. But what we're seeing now is that platform engineering is becoming the main consumer of Dapr. And if we look at this, for example, we can see that the platform is centralized and it has a bunch of consumers. And the consumers for a platform team, as you probably know, are internal functions within the organization. Now, if you take a look, we have an app dev team, an infosec team, and an ops team. They're all consuming the platform. And if you look at the right, it's all very infrastructure focused. So the app dev team, actually, if you pay attention, they don't really have much to do with self-service pipelines or infrastructure provisioning or container platforms or monitoring tools. They want their stuff monitored, they want their stuff to run. The platform team doesn't want them to do it themselves because they want them to focus on business logic. And so the platform encapsulates these concerns via APIs. But what we're hearing from more and more organizations is that there is a missing piece. What about the API interaction piece with the underlying infrastructure that so far you've been focused on provisioning and monitoring? And this is really where Dapr comes into play here. So if we look at this, this is a complex slide, but we'll break it down. If you look at the stuff on the top, application code and application frameworks, this encapsulates basically every person developer that can shoot something and kill it when it comes to infrastructure, right? So you can mess up compute, you can mess up networking, you can mess up storage, cloud services in any number of ways using any code running on any platform. And so platform teams want to give developers golden paths, really these best practices in a box. And this is really where Dapr comes in as a platform play. Fairly recently, in the last, I think, a year and a half, we've been seeing a great uptake of Dapr just making its way into major enterprise platforms. So with these APIs, developers get programming models like workflows, actors, the ability to talk to state management APIs, talk to their databases, message brokers, caches, secret stores, all through Dapr, and they know that they have reliability and security best practices built in off the shelf. They do not need to reinvent the wheel or reinvent the pattern, really. So let's move forward into some feature highlights that we have for Dapr 115 and beyond. And I'm also going to cover something that's in 114, and that is streaming PubSub, which is receiving a major update in Dapr 115. So Dapr allows you to abstract PubSub message brokers. For example, if you're an organization and you're picking, let's say, Kafka today, and then 6 months down the line, you find out that Kafka isn't able to answer your requirements and you need to tear it out, this might be $1 million or a $5 million operation for you. It can get very costly just to rip the entire thing out from your code base. With Dapr, it literally takes 1 minute or 5 minutes if you need to tweak some specific settings to the next message broker that you're getting. So Dapr has had up until now a delivery model where it would invoke the application via HTTP or gRPC, but now in 115 we have streaming PubSub, which increases performance and makes things a whole lot simpler, because now you can pull events from Dapr instead of having Dapr push the events for you without actually needing to host them. So this is supported for Python, Java, Go, and C# in 115. Currently in 114, I believe it's just Go. And let's see a demo of what this looks like. So I'm going to go into my VS Code, and my example in this case is Go, but this can be done using the Dapr SDK from literally any other language. So if you're new to Dapr, this is all you will need to interact with your underlying infrastructure, just these lines of code. You initialize the Dapr client, and that single Dapr client is now your entry point to the cloud or to any infrastructure that you're running on premises or on the edge. Some big companies even run Dapr on edge and on very small controllers, which is interesting. Some run them in cars. So there's lots of use cases, but it will all boil down to just having a Dapr client that talks to whatever infrastructure you have. And so now, instead of opening up a web server and having an endpoint that listens for Dapr to basically send events, you can now say, hey, Dapr, I want to subscribe. And you can actually subscribe dynamically. And of course, this code remains the same, whether you're configuring Dapr to work against Pulsar, Kafka, RabbitMQ, AWS SQS, Azure Service Bus, any of the 15+ message brokers that Dapr supports. And this is really good for back pressure, which I mentioned on the slide earlier, because if you have a push model, that's great. For example, if you're running in a function-based environment where you're scaling up and down based on incoming HTTP events, then you might say, hey, look, I want to track the HTTP events that are coming into my app, and then scale down if there is nothing coming in within the last 5 minutes. But in many cases, especially high perf cases, you want something to be up and running, to be constantly pulling messages, and then also deciding when it can process the next message, which is very, very tricky with push-based messaging. So Dapr allows you to do that. If you can see here, we basically have a loop that will just receive 3 events. This is a very simple for loop. I will just zoom in a little. And the difference is that now you can ask Dapr to receive messages. And you can receive them, and you can also acknowledge the messages independently. And we will also have a batch version of this coming. So the nice thing about this is, even if you're talking to an underlying message broker or a queuing system that itself only supports push, Dapr will actually give you a pull model on top of it, which is extremely special because this is incredibly hard to do. So if you are constrained to use a push-based PubSub broker for whatever reason, but you find out that you want to apply back pressure from your application, you want to do it, Dapr will give you that functionality. It will actually serve as a buffer. So this is extremely useful for high perf scenarios. And let's run a simple demo of that. I'm going to just use the Dapr CLI. What you're going to see here today is me doing Dapr run. That's a tool of Dapr that runs a local Dapr sidecar on my machine and then launches the app. It's just a necessity if I want to develop quickly, but it's really not a necessity. You can run them separately, but it's very nice to run them together because it'll just give you a single log session for both the Dapr sidecar and your application. So the next part is not too interesting. I'm just publishing messages. This code is just regular dapr.publish. We're not seeing that in code, but we can see that it successfully published messages. And now I am going to run the subscriber. So here's the Dapr run command. This is going to run the Dapr sidecar, and this is just going to run my Go code afterwards. And we will run this. and we can see that we pulled all the messages using the pull-based model. So this is coming in 1.15, very high scale performance. This supports every message broker that Dapr supports. So all of them. If you're using Dapr today, you know that Dapr sometimes supports some components and some it doesn't. This is going to support literally all of them. Let's go back to the slides. All right. Yes, that was the demo. Stable workflows. Workflows is an extremely interesting programming model. If you think about it, any type of application in the world today is a type of a workflow. You basically have something that you want to do and you want to get it done. You want to make sure that it runs to completion and that if it fails, it will re-trigger and hydrate its state and that it'll do it in a performant way. Dapr has a native programming model that supports Java, Python, C#, JavaScript, Go, Rust, and we have a PHP maintainer coming back after a long vacation to Dapr, and we're going to have workflows in PHP, which is going to be interesting, seeing workflows meet the language of the web, the old web anyway. So that's going to be nice. Oh, yes, and yeah, no, I mentioned all of them. So up until now, workflows were not production ready, and a lot of big companies took it into production, even though we told them not to, because it didn't scale very well. If you were using, 100 workflows or 150 workflows and you only had one instance of your application, then it would have been fine. But any more than that, then the workflows might have not triggered to the end, which is not something you want in the workflow. But now we can actually scale them to millions of workflows running concurrently within your cluster, tens of thousands of activities. And this is really, really great for literally any type of system. One interesting use case we're seeing for that is agentic workloads in AI. If you look through Dapr Discord, you'll find many users talking about that. Data processing is another really interesting example. It's a really, really simple programming model that allows you to do things like sequential activities, right? You want to get an order and then send an email, and then after the email is done, you want to verify it and then send it to another subscriber. Well, you can basically just write your code that simple, and Dapr will make sure that the workflow runs to completion. If any of these activities fail, Dapr will hydrate the state, and it will pick up where it left off and make sure that this thing finishes. You can also do parallel workflows. This looks like the MapReduce of old. This is just parallel execution model. You can get a lot of state, you can send it off to different parts of your system, wait until they all finish, and when they finish, you can then kick off another parallel workflow or start another sequential one. So this gives you a lot of power. The monitor pattern that Dapr supports is pretty interesting. If you're looking at this and you're thinking Kubernetes, or you have this association with Kubernetes, is because this is essentially Kubernetes. The Kubernetes API server is a reconciliation loop, and using the Dapr workflow monitor pattern, you can write your own Kubernetes API servers. Now, whether or not you'd actually like to do something like that, that's up to you. But if you want your own reconciliation loop, which is a very nice programming model, you can do that with Dapr workflows very, very quickly. Dapr workflows integrates with whatever database you have. Postgres, MySQL, DynamoDB, CockroachDB, literally any database that Dapr supports can almost support this. Most of our databases are transactional, so they will support workflows. So this monitor pattern is interesting. You can use it for status verification. You kick something off. You want to make sure that your users can pull its status. So this will create a fairly reliable reconciliation loop for you. Also coming up in 1.15 is the conversational API. A lot of people have been asking us, hey, how does Dapr relate to AI? And for a very long time, we didn't have a good answer because we in the project just don't want to put AI someplace if there isn't a good reason to do that. But developers were coming to us fairly recently and going, hey, look, we're planning for these AI systems to meet production 25, start part of 26 fairly soon. And we have a complexity because we're not native Python developers. We're not native C++ developers. We don't have the client driver knowledge required to interact with these models, especially if these are custom models that we're running on-prem. And so Dapr comes in 1.15 with this API to reduce the entire complexity of interacting with these LLMs. It launches with support for AWS Bedrock, Hugging Face, OpenAI, Anthropic, and Mistral. And it'll give you a single API and entry point into this world that you can use from literally any language. The HTTP interface is really easy. Actually, this is what I'm going to do in my demo today. But it doesn't just stop there. Enterprise requirements are wide when it comes to LLMs. For example, sensitive data is a thing. It's an issue. It's a big security issue because you don't necessarily control the user prompts, and trying to figure out if a user prompt contains sensitive data is a very complex piece of work. You need to talk to other APIs or pay for them or bring in specific libraries that might not actually give you what you need, and there's not too many of those. And then if the LLM actually outputs data back, if this is custom trained data, you have no guarantee that it's not just gonna be susceptible to an injection prompt attack and give out a user's mail, name, credit card, or any other important information. And so Dapr actually gives you the ability with just a single flag on the API call to obfuscate PII data that is both incoming into the LLM and going outside, which is incredibly important. Prompt caching is also really important, and I will show that. I bet no one likes to pay for egress traffic. A lot of LLM providers do support prompt caching, which is to say, if you ask an LLM, hey, what's the time now in Portugal? And the LLM will answer, and then you ask it again 10 more times. You don't want to hit the API and pay for these calls, right? That's redundant. Some models, not all of them, surprisingly, have prompt caching enabled, but even if they do, they will actually charge you money for the first time you need to put the hit into the cache itself, and that will be costly. And even then, if there is a cache hit, you will pay about 50% of the call, and there will also be egress latency. So for example, if you're going in from AWS to an LLM provider that is hosted someplace else, or just another AWS account or another region, you will also pay for egress cost. Well, with Dapr and prompt caching, the cache doesn't leave the Dapr sidecar, which is really, really great because you're not paying for network, you're not paying 50% of that second call that hits the cache, you're not paying for the call to actually insert it into the cache, and this is great. I'm going to show this, and I'm literally going to put my money where my mouth is. So let's take a look at what this looks like from just an architectural perspective. You have your app talking to Dapr. Dapr talks to all of these APIs with a single API that I'll show you in a second, and Dapr will also be adding more and more features like sensitive data obfuscation and prompt caching into its layer. Okay, so let's give a demo. Will the demo gods be with me today? That'll be interesting. This is still in master branch. Master branch is not very stable, but yeah, let's hope this is going to work. Okay, so I have Python code here. Can you all see it all right? For me, it's kind of inconvenient, but we'll try and deal with that. I'm just going to zoom out just a little bit. Okay, so a very simple thing. I have an input here. This is literally what we care about. This is an array of inputs. Now we're going to be testing out the sensitive data obfuscation feature of Dapr. So Dapr ships with an echo component. Yes, you can connect it to all of the LLM providers I mentioned, but we've also included an echo component, which is really good for mocking and testing. Echo will essentially take the input and just return it as is. So if you just want to, test things locally, this is really great. We're going to use this to show the PII data obfuscation because I am generating an input, and we will see it basically go back to us, obfuscated, hopefully. So this is the input itself, and this is just time I'm measuring latency. We'll need that for the other demo. And here is the crux of how we're calling Dapr. This is essentially all you need. You basically call the conversation API. This is the echo component. So this is the YAML file. This is all I need to tell Dapr to connect to the echo component that ships by default with it. And I'm just calling the converse method, and I'm just giving it this input here. And I have scrub PII true, which means if you identify any PII in the input message, please obfuscate it. So when the echo component basically brings it back to us, we should not see it, hopefully. So this then prints it, and we're good to go. I have one iteration here for this. We really don't need more than that. So I'm just going to run Dapr run again. Again, the CLI, I'm going to be creating a Dapr sidecar, and then I'm going to be launching this Python app that's going to call into Dapr and execute this. So let's see how this goes. This is the logs of Dapr sidecar, and we see that we got the response back, hi there user, email address. We will also be enabling you to configure exactly what type of PII data you want to obfuscate, whether it's credit cards, names, emails, social security numbers, etc. So this is a really nice enterprise feature that is pretty hard to implement, and we've heard is important for a lot of developers just reaching into the unknown of AI input and output. In regards to prompt caching, I am going to go back into my code, and what I'm going to do now is switch the inputs. So I am commenting this input, and I'm commenting out that input. And now we're going to talk to OpenAI in this case, and we're going to ask OpenAI, where can we get great grilled cheese in Salt Lake City? Now, I did try this. You don't want to ask something that doesn't have a sense of taste. What's the best place to eat? It won't give you a good outcome. So we are going to have this input going in, and this is my OpenAI component. Looks fairly similar to the Echo one. I am grabbing a secret because I'm talking to OpenAI now, to the live service, of course. I don't want to expose my key. So I'm using a local secret store that Dapr ships with. Dapr allows you to save local secrets and then reference them. This is what I have here. Nothing too fancy about this. And I'm using a model called GPT 3.5. So if you go on the OpenAI website, which we can actually do together right now, and we look at prompt caching, we can see that prompt caching isn't supported for this particular model with OpenAI. So, and you would probably want to use Dapr anyway, even if it was a model that did support that because of the other associated costs with it. But for now, we want to make sure that we have zero caching enabled on this. So we're using this model, we're getting the key. This is all fairly simple. And I have this input, and what I'm going to do now is just switch Echo to target OpenAI. And the last thing we're going to do is we're actually going to go into this billing portal here. And what you see here on the right is my company credit card. This has a lot of money in it. And the other credit card that I have here is my own personal credit card here in my pocket that does not have the same amount of money as the one on the right. I can assure you that. It aspires to have that same amount of money one day for sure, but I can assure you it's way far off from there. So we're going to go ahead and make this one the default. And yes, no, we are the default. This is not the default. This is exactly what we want. I'm asking myself, this is a really good idea at this point. Let's go back here. And yes, okay, so it's a very, very good thing that I didn't do this before. So we have the input here, and I'm just gonna, run one simple query. Actually, let me put that. You know what? I'm gonna stay with my credit card because we're just gonna launch a single iteration of this. So hopefully this is gonna go well. This is actually gonna cost me money, but that's fine. It's just a single call. So I think I have everything here. Yeah, I have the input. I have OpenAI configured here. Yeah, and I just want to see, the latency for a single call for OpenAI. So I'm just gonna launch this one call. I really hope it's going to be only one call, yes. And so we're getting the response back. Yeah, I wouldn't trust this thing. And it took 1.7 seconds. So it's fairly lengthy because it did go into the OpenAI service, made its way over through the Wi-Fi here. And that is costly and time-consuming, and the latency is not good for user experience. You want it to be as low as possible. So what we're going to do now is remain with my credit card on the line and issue, let's say, 10,000 calls. Okay, and now, and I really hope I don't have any typos, so please be with me here. We're going to add yet another flag, which is called cache TTL, and I'm going to tell it to cache the response semantically for the next 5 minutes. Cache TTL. Okay, this is how I remember it is from the source code. This should be fine, and we should be also seeing a message that you didn't see here, which says response cached. So hopefully we're going to see that. Okay, now we're going to go back. We have 10,000 iterations. Yeah, let's kick this off. But before I do, we need to have a chat, you and I. If this doesn't work, I might need a place to crash next month. So I'm a great conversationalist. I pull my own way around the house. If you'll have me, yes, come talk to me afterwards. Okay, cool. Let's run this thing. And yes, we can see cached response, and this is really, really, really fast. As you can see, you can see the scroll over here on the right. Yeah, this is about 5-6 milliseconds worth of latency, and you basically get cached responses that do not leave the Dapr sidecar. You don't pay ingress costs, you don't pay the cost of inserting it into the cache, and you can work with literally any model, even models that don't support prompt caching at all. So yeah, this is what we have here for this. Let's go back into the slides. Really happy this worked. I just need to remember to switch back my card. I'll do that after. Yeah, Wit, please remind me of that. It's on you, okay? Cool. So beyond Dapr 115, Dapr today has a state API that allows you to talk to a lot of key value stores. But users have been telling us, hey, what about SQL queries? We really want those. What about blob storage queries or uploads? What about document store interactions with semi-structured data? And this has been planned for years. We finally have some sort of a plan. One thing I'll ask you to do is go into the Dapr proposals repository, look for these issues, see if you like our design proposal, and then just upvote them or just write your opinion on there. It really helps us figure out what the right direction is. Longer term roadmap, these are all open proposals that we have in the open. The ability to add list to our existing key value store. So we're taking small steps into making state a really first-class citizen within Dapr, but something that will help a lot of users is just to be able to list the keys in an existing key value store. Another open proposal that we have is delayed pub sub. Delayed pub sub is great because now that we have scheduling in Dapr using workflows, we use that as the infrastructure for pub sub to do things like being able to tell Dapr to publish a message that will actually fire off not now, but in a year from now, or in 5 years from now. So you'll go, hey, Dapr, publish this message, and execute it at the time of my need. Authorization API, this is something like OPA just built into Dapr. So you will essentially have an RBAC permission model inside of the Dapr sidecar, and that will work with schemas that you will have for your databases. It's all in the proposal, go check it out. It's pretty nice. And why don't we have HDMI? Let me try and bring that back in. Okay, so authorization API, RBAC system, scopes, user roles, everything you need to basically create RBACs within your databases without needing to create explicit tables or code an entire layer of RBAC permissions within your own business logic. And especially from the platform perspective, you have polyglot languages and you want them all to use a centralized authorization platform, that will essentially give you that for free. And another proposal that we have fairly recently is from a community member that wants to do search via Dapr, so the ability to search over large unstructured texts. And yeah, please go look at these proposals, give us your feedback. It's really important. Maintainer roadmap. This is stuff that's important to us maintainers. We really want to integrate with Cert Manager, another newly graduated CNCF project, to be able to provision third-party certificates for the Dapr project. Today you can bring your own. It's a fairly complex process, if we're honest about it. We really want to make it easier for people who already have Cert Manager within their environments to hook up Dapr into these certificates. We have a jobs API. We released that in Dapr 114. It allows you to do distributed scheduling at scale. It's a cron API. You basically go to Dapr and say, hey, Dapr, I want you to invoke my app every week on the Tuesday at 5 p.m. Central time. And Dapr will essentially do that and make sure that this hits only one instance of your application, no matter how many applications you have. We have a distributed lock API, which makes it really easy to write leader elections, 3 lines of code, I swear. You basically say, hey, I have a bunch of instances that are running. I want to make sure that only one of them is active at any single point in time. This is a really complex distributed systems problem that Dapr encapsulates very, very easily. There's lots of users for that, more showing up recently. It's currently alpha. We really want to make it stable because this is hindering large enterprises to take it into production. And bulk pub sub is something that we've had in Dapr for a very long while, high throughput, low latency scenarios. Thank you for the reminder. For Dapr, scenarios for Dapr where you can actually get a batch of events being streamed into your application. So we want to advance that to stable too. This is being used in production by a lot of companies. The only thing we're missing is documentation probably, and support for 1 or 2 SDKs just to make the consumption side easier. Okay, and finally, I have a special thank you to everyone here, community members, people who are just interested in the project, maintainers, just people who are coming to talk to us about what their needs. Because Dapr has graduated CNCF, it has been announced yesterday, and we couldn't be more excited. We're only getting started. So with this, I will lock. Thank you so much.